Hello and welcome to this video lesson on patterns and algebra, where I will be introducing functions. Our learning goals are: I can identify the dependent and independent variables in a given situation, including situations involving change over time. I can describe the rule that determines the values of the dependent variable from values of the independent variable. I can represent corresponding values of the independent and dependent variables of a function in a table of values. I can determine the value of the independent variable of a function given the corresponding value of the dependent variable. And our language goals are: I can talk about patterns using words like independent variable, dependent variable, function, table of values, input, and output. Take a look at the picture here. It represents what we call an input-output machine. Any number that is put into this machine is multiplied by 5, and you can see that by the times 5 symbol in the middle of the machine. So when we input 6, the output is 30, because 6 times 5 equals 30. Let's take another look at this input-output machine. Suppose we enter 9 in the input. What will the output be? Did you say 45? If so, give yourself a big pat on the back because you got the answer right. 9 is our input. It goes in the machine. The machine multiplies the input by 5. 9 times 5 equals 45. So our output is 45. And that is how input-output machines work. We can use an input-output machine to show a changing quantity or amount. In this example, the changes in the machine make a growing pattern. You can see that each output corresponds directly to an input. We call this correspondence a function. We also have special mathematical names for the input and output. We call them variables. The input is called the independent variable, and the output is called the dependent variable. Let's review the vocabulary we just learned. A function is a correspondence between two changing quantities represented by independent and dependent variables. Great definition. It's a mouthful. It has a lot of kind of challenging words in it, so let's break it down a little bit. First of all, what's a correspondence? Well, a correspondence is just a relationship or a connection, okay? So we can say a function is a connection between two changing quantities, okay? So it's a connection. What does quantities mean? Well, it just means amounts, or in this case, just the numbers, okay? So the numbers represent the quantity or the amount or the value, okay? So we can say a function is a connection between two changing numbers, but we know that those numbers represent an amount of something, okay? And then the input and output are represented by independent and dependent variables, okay? So it's a connection between two changing numbers represented by independent and dependent variables. And I know I didn't define those because I'm just about to do that now. So the independent variable is the same as the input value in a table of values, which is what we call a table like this one here. It's a table that has values in it. So it's a table of values. Okay, so the independent variable is the same as the input value on the table of values. We call it independent because it doesn't change as a result of the function. The number you put in the input is whatever number you decide to put in the input. The only thing that changes is the output after you do the function to it. A dependent variable then is the output value in a table of values, and it's dependent because it does change. Okay, it's called dependent because it depends on the function, right? So we can put this first value in, 1. That's just a number we picked, 1, and then we do the function to it. We add 8. The output depends on the function. The output value is always going to depend on whatever the rule is in the function machine. That's why we call it dependent. Some function machines do 2 steps. So they have a first step, you get a little answer for the in-between, and then you do something else to it. So this particular function machine right here, it doubles each input, and then it adds 6. If our input is 6, we double 6, 6 times 2, and our middle value or intermediate value is 12. And then the next step is add 6. So our output will be 18. Okay, here's another question for you. We're going to use the same function, the same rule relating the input to the output, and that is multiply the input by 2 or double the input, then add 6. Okay, so follow that pattern rule and predict what you would get if the input was 8. Okay, let's take a look at this table of values. Which column in this table represents the independent variable? Well, the independent variable always goes in the first column, the input column, and the dependent variable always goes in the second column, the output column. It's important to know as well that a table of values might be flipped the other way. It might be horizontal. So it might have only 2 rows and many columns instead of having only 2 columns and many rows. In the case of a horizontal table of values like this one here, the input value or independent variable always goes first again, and the output value or dependent variable always goes second. Let's talk a little bit about change over time because functions often represent something that changes over a period of time. Here's an example. This graph shows how a mug of hot chocolate cooled over time. So the x-axis values show us the time, and the y-axis values show us the temperature. The graph shows the connection or the correspondence between time and temperature for this particular mug of fictional hot chocolate. It shows the relationship between the temperature and the time, and that makes it a function. But to do this, we need to know which variable is the independent variable and which is the dependent variable. Remember, an independent variable is the same as the input value in a table of values, and it's called independent because it doesn't change as a result of the function. And the dependent variable is the same as the output values in a table of values, and it is called dependent because it does change depending on the function. For our example of the mug of hot chocolate getting cooler and cooler over time, let's look closely at the graph and think about it. The graph shows the relationship or connection between the amount of time that has passed and the temperature of the hot chocolate. In this case, the temperature of the hot chocolate is dependent on the passing of time. As time passes, the hot chocolate cools down. So the independent variable is time, and the dependent variable is temperature. So if we were filling in this table of values, we would show the time in minutes in the first column and the temperature in degrees Celsius in the second column. We'll learn how we can represent a table of values on a graph in the Cartesian plane in a future lesson. So let's leave this for now and we'll pick up on it next time.